everyone, I am Bhavna, 6th semester, Electronics and Communication Department of Sri Venkateswara College of Engineering. Today, let us deal with the subject microwave theory and antennas. In that, let us deal with the topic antenna design and radiation pattern visualization. Abstract. Characteristics and the radiation patterns, parameters of the antenna system. This program of many antenna geometries and antenna arrays allows for the design and visualization of both can be evaluated but not easily visualized. The visualization option in the developed to allow for 2D and 3D visualization program allows for the inspection of the radiation pattern for many different types radiation pattern in full 3D or in multiple 2D of antennas and antenna arrays. Introduction. In the course of designing an antenna, element or parameters for this type of element, many of an array of elements, it often becomes useful to element types have various configurations and have a method of visualizing the radiation subtypes available in the program. For example, a pattern and for determining the consistent if a dipole is selected. The user may choose the type of dipole, thin wire, thick cylindrical, small length, maximum current or far field distance. So this is the program window showing a dipole pattern for L means the length which is equal to 1.5 lambda, nothing but the length which is equal to 1.5 wavelength. So that is it is one of the program. The windows showing a dipole moment for L is equal to 1.5 lambdas. So it's a diagram, it's one of the figure which shows the program windows for an dipole moment pattern for L is equal to 1.5 lambda. Now, the next topic is single element simulation. Since the radiation pattern and consistent tools are also integrated into the package, two parameters for many common type of element allow for automatically determining the best are well known. Calculating the radiation configuration for an array or an element to meet patterns is performed in a straightforward, predetermined radiation characteristics matter. It is about the single element simulation. The next topic is about, before that, the pattern window showing the various 3D and 2D plots are shown in the figure. So it is one of the figure which shows the pattern window for showing the various 3D and 2D plots. So it shows the 3D and the 2D plots of an antenna. It's one of the geometrical representation of it. It's one of the figure. The next topic is swept parameters, a very useful tool in an antenna design and parameter and display the results either as and simulation allows for the program to sweep over animated figure in the pattern window for the set range of parameters with the swept type of plot being displayed, or they may step parameter tool the user may select any one of the through the swept one plot at the time to examine the active parameters to sweep across. So it is a sweeping a dipole from L is equal to 1 meter to 2 meter where lambda is equals to 1 meter. It's a figure which shows a sweeping a dipole from where L is equals to 1 meter to 2 meter having the wavelength which is equals to 1 meter. It's one of the geometric representation of sweeping a dipole from L is equal to 1 meter to 2 meter where lambda is equals to 1 meter. The next thing is about the antenna arrays. One of the main feature of the program allows depending on an array type and for the design of any type of array of common corresponding array factor is generated. The elements from the main window, the user may array factor itself may be viewed or a composite select any one of the 1D, 2D or 3D array pattern of the array made with selected element types. It's one of the dimensions of 1D, 2D and 3D. One dimensional, two dimensional and three dimensional array pattern of an array made with selected element types. So it's one of the shown figure. So it's one of the figure representation where the radiation pattern for an arrays of isotropic elements for the Fourier synthesized 1D array, or it's a circular 2D array and the planar array and a spherical array. So the first A figure, it shows the Fourier synthesized one-dimensional array. So first figure shows the Fourier synthesized one-dimensional array, and the B figure shows the circular two-dimensional array. The B figure shows a circular two-dimensional array, and the C figure shows the planar array, as well as the D figure in the screen shows the spherical array. So these are the four important array patterns which it can be shown. The next thing is the array element window and array builder window. And the array element window as well as the array builder window. It's one of the figure, the presentation of the array element window as well as the array builder windows. And alternatively, the program allows for the analysis explore antenna pattern and its properties, and a visualization of the commonly arbitrary arrays promotes the greater understanding of antenna of elements. In order to accomplish this, the element design features provide a program include what is known as a good platform for design and visualization, the array builder. This is a small subprogram that array features allows the interactive designs allows for the playout and weaving of an array and visualization of many different type of element. So it's one of the representation of it. Next is about conclusion. The program successfully allows the user to for the use of the pattern generated from the other interactive designs and visualize many common programs are gathered from real antenna on and type of antennas as well as an array of element. Array range to be used as an element when it has greater utility not only in its use as a design analyzing the arrays program for antennas but as a learning tool as well. So it's one of the conclusion where the program successfully allows the user for the use of the pattern generated from the other interactive designs and visualize the many common programs are gathered from the real antenna on and types of antennas as well as the arrays of element where antenna range to use as an element when it is used as a property. Next thing is about the references. So the first reference is W.L. Stutzman, nothing but the antenna theory and design, second edition, John William Ansons in 1997. The second thing is C.A. Balnas, antenna theory and analysis and design. Analyze and design, second edition, John Wyman and Sons, Inc., 1996. The other two references of this uh, program. So at Z. Wisbani joined the faculty at the University of the Mississippi in August 1987 as an assistant professor of electrical engineering. He adopted to the rank of the associate professor on July 1991 and to the rank of the professor on July 1997. He spent a sabbatical term in 1996 at the Electrical University of California at Los Angeles, USLA, and the second person was Matic George Inman, was born in Dayton on February 7th, 1978. He received his BS and MS in electrical engineering from the University of Mississippi in 2000 and 2002 respectively. He currently publishing an PhD degree in electromagnetics there. He is currently employed at a university as a research assistant and graduated instructor teaching a number of undergraduate courses. His interest involves electromagnetic theories, numerical techniques, antenna design and visualization. So thank you all. Thank you for the session.